Hello and welcome. In this lesson, we'll explore solving logarithmic equations and we'll take a look at a variety of examples. So let's start with example 1, where we have log with base 3 of 9 plus log with base 3 of x equals log with base 3 of 24. So we call this a logarithmic equation because every term is expressed in logarithmic form. Step 1 to solving such equations is inspecting the base of each term. We want all the bases to be the same because when solving logarithmic equations, and as a matter of fact, any equations, we have to combine terms. And we cannot combine logarithmic terms unless they have the same base. Step number 2 is we'll combine the terms on the left side together and the terms on the right side together. So on the left side, we have the addition of two log terms, which means that the two log terms are connected to each other by the product of the expressions inside the log. So in other words, we have log with base 3, so the base stays the same, and we multiply the terms that are inside the log, so 9 times x. On the right side, we only have log with base 3 of 24, so nothing to combine in there, so we'll just write log with base 3 of 24 as is. So in this step now, you can see that we have a single log term on each side. The bases are the same, and obviously there are two equal terms, which tells us that the expressions inside the log must be equal. So in this step, we equate the expressions inside each log. So 9x equals 24, and this has turned into a simple linear equation now. So that would be 24 over 9, reduced to lowest terms possible. So that means both divisible by 3. 24 over 3 is 8, and 9 divided by 3 is 3. So the answer is x equals 8 over 3. Now the last step in solving a logarithmic equation is testing whether the solution is acceptable or not. Remember that when we graph logarithmic functions, we emphasize that the expression inside the log has to be a positive number. And since x, or our unknown, was inside the log, we have to make sure that this answer will make sense for the term. So 8 over 3 is a positive number, which means that this is an acceptable solution. Let's move on to the next example. We have log with base 7 of x squared equals log with base 7 of 16. So as you can see in here, we have a single term on each side of the equation. We have a base 7 in both log terms, which means that we can jump into the step when we equate the expressions inside each log. So x squared equals 16 would leave us with x equals plus or minus the square root of 16, which is basically plus or minus 4. Now, as you can see in here, we obtain two solutions, x equals negative and positive 4. Now we want to check and see if both solutions make sense. So we are going to substitute this x value in the log term that contains x. So if x equals negative 4, log with base 7 of negative 4 squared will be log with base 7 of number 16. And this term exists, so the expression inside is positive. So in the same way, you test the next solution, which is log with base 7 again of 4 squared, which is log with base 7 of 16. And we're going to say that both solutions are acceptable, and therefore there will be two solutions for this equation, x equals negative 4 and x equals positive 4. So let's move on to the next equation. Now, what we have in this case is two terms connected to each other by subtraction sign and a constant term on the other side. So you probably noticed that we have log terms on the left and just regular normal terms, so just a constant on the other side. This is still a logarithmic equation, so we are going to combine the terms on the left side or combine the log terms together and leave just a number on the other side. Remember that when the base is not written, that means the base must be 10. So since we have subtraction, it means that we have to use the quotient law. So we have log with base 10. Obviously, we don't have to write it. when the base is 10, but we're going to write this for an obvious reason, which I will explain shortly. So we have log with base 10 of 2x over 148 equals 2. Now, remember that our unknown is in the numerator, so it's inside the log. And in order to solve for the unknown, we need to express this expression in here. So whatever is inside the log in exponential form. So we're going to convert, in other words, this logarithmic statement into an exponential statement. So that means that 2x over 148 equals the base 10 to the power of 2. Now 2x over 148 is equal to x over 74, so reduce, why not? And that 10 squared equals 100. So solve for x, multiply both sides by 74, and we have 740 as a solution. So this is the first set of examples, and we are going to move on to the next set of questions. And for this, please follow the next video. Thanks for watching.